This section we're talking about importing datasets with Python. And in this video, we're going to go through reading files and creating data structures. So, looking back at the second video of the first section, in the last video we went through what is WinPython, why you should install it if you're doing data science on Windows, and what kind of components in terms of Python libraries and modules that are present within WinPython. In this video, what we're going to do is to go through how we can read some common file formats that you see data scientists produce, and how we can use that to create interesting Python data structures that represent the data. Now, in in1, I am opening a very simple text file. So you might ask, it's just this text file, who is going to distribute data in this way? But as you move into more specialized formats, you would read text files a lot. For example, when you're analyzing text data, natural language data, emails, chatbot chat scripts, and generally any sort of unstructured data that somebody might throw at you. In fact, one of the main advantages you have as a data scientist is the ability to take any sort of messy data and transform it into something useful and further create some actionable analytics or predictive analytics using machine learning downstream. So it's very important to start at the basics and think about how reading text files and so on and so forth actually works and how we can use that to our advantage. In in1, we first use the with statement to use what's called a context manager in Python. And so what this is we are looking at opening the 111.txt as a file in the context manager. So why do you need to use a context manager? Contrast this with the traditional way of simply opening the data by using, let's say, file handler equals open chapter 111.txt, and then you do data equals to file handler.read. At some point, you need to remember to close the file handler, because if you open too many file handlers, your system would crash. This is a lot of cognitive overhead that as programmers, we don't really want. So the idea here is we use with, which starts a context manager around the open call, so that when everything inside the with statement terminates, the open file handler is automatically closed, so there's no ambiguity on when and where we need to close this file handler. So with open, I first specify the file name, which is the chapter 111.txt. In the second argument of open, I am specifying that I only want to read this file and not write to this file, which is why the second argument has a single character R. I want to pipe the context, or the file handler context, into a variable called f, which is why it's with open chapter 111.txt as f. And then within this context, I can open and read the file handler by calling f.read. With this data, I then pipe this into a variable called data. Let's first look at what's in data. In in2, in Jupyter Notebook, I can simply state the name of a variable for Jupyter Notebook to print out in its outputs the contents of this variable or the value of this variable. So in in2, I simply put data, and after executing this cell, I would see in out2 the data present in the text file, which is clients, Smith, John. This is a fairly common sort of line of data that we see. So one of the things we can do is to try to separate the logical elements in this line of data. In in3, I am splitting the line of data by the colon, which produces a data structure that is a list that contains two elements. These two elements are of type string, where the first element reads clients and the second element is Smith John. So we've progressed one step further ahead to splitting the string into their logical elements. However, while the first element contains only clients and it says very nicely, this is the type of the data, the second element, i.e. Smith John, is still a concatenated version of the first name and the last name. What we can do is use an index here, specifying that we want to first split the data with the colon, and then access the second element indexed by the integer 1, because all indices in basically all programming starts at 0. The next step is to remove the white space before and after the data. In int6, I am assigning the variable full name with the split data, accessing the second element and stripping the white space using the function .strip. I print full name as a variable, and out comes Smith John. I can split this name further by calling full name.split with a comma, but then I end up with the same problem, where while the first part of the list has a tidy data point, which is Smith, the second part has a space that we do not want. So there's two ways of going about this. In the first method, we use what's called a list comprehension, which I'm sure you're familiar with, by first splitting the full name into two parts, and for each part, we strip the white space from the full name. We then end up with a list of two items where they're clean names of the data. In the second method, I'm using a trick where I split the full name not by a comma, but by a comma and a space. That means that the space is removed as a part of the split call. Apart from a text file, a very common and popular data format for data science is JSON files. How do we deal with this? In int12, I'm first importing the JSON module from Python. So the thing is, we can actually simply read JSON files as normal files. So again, we here start a context manager with open chapter 112.json, store the context manager as a variable f, read from f, store it in data, and print out data. And if we print out the data, we can see that in out12, it's sort of gibberish. Doesn't really reflect this nice data structure that JSON gives us. So how do we combat this? In int13, we're using the loads function, which stands for load string, which allows you to load a JSON data structure from a string. Because we've already read the file contents from the file handler into the variable data, we simply need to use load string to put it into a structured JSON format. In out13, you can see that it's very clear that we have parsed the JSON file successfully, and we see a list of 5 dictionaries, each containing some interesting information. One of the easiest ways for us to ascertain what sort of data structure we're leveraging in Python is to use the magic function type. So type, if we look at the type of JSON loads data, it's a list, and if we look at the type of the first item in this list, it's a dictionary. And that's all there is to it. So in the next video, I'm going to show you how we can use data science libraries like NumPy and Pandas to import your first datasets into Python. Let's check it out next time.